Hey everyone, I'm Professor Huntington and I'm back to discuss problem solving. Before we get into it, I'd like you to think about the difference between an exercise in math class and a problem in math class. An exercise is practicing a skill that you already know, okay? And with a problem, it's an opportunity to develop new strategies. With an exercise, it's going to be a familiar situation, something you've seen before. And with a problem, you're getting stuck because you don't know what to do and you've never seen it before. With an exercise, it's also going to be clear and straightforward. But with a problem, it might have multiple methods of solving and it might have multiple answers. There was one person who really shed light on problem solving as an art and as something that's more formal that we can focus on. And his name is George Polya. He is a Hungarian-American mathematician, and he wrote a book in 1945 called How to Solve It. And in this book, he described 4 phases of solving problems. First phase is to understand the problem. Duh. I mean, come on. But seriously, that's something that we overlook if we don't focus on this as a step. Second thing is to devise a plan to solve the problem. So this is where it's tricky and you have to think of different heuristics, which is a word he coined for basically strategies, problem-solving strategies. And third thing is to carry out that plan. And then at the end, you want to not move on to the next thing, but instead you want to look back and you want to ask yourself things like, does my answer seem reasonable, and can I use this result in some future problems? Or how does this apply to the big picture here? So here's a copy of his book. And as I said, understanding the problem is often overlooked. So when we're at that phase, some questions we should ask ourselves are, what are you asked to find or show? Can you restate the problem in your own words? Can you think of a picture or a diagram that might help you understand the problem? Is there enough information to enable you to find a solution? Do you understand all of the words used in stating the problem? And do you need to ask a question to get an answer? So I'm going to focus on each phase now a little more carefully. So with understanding the problem, first, usually it's a problem that we have to read. So, it's text-based, so you want to read it carefully, sometimes reread it. And while you're doing this, you might want to consider creating a list and trying to really sort out that information. You could also make a sketch and label that information to help you understand the problem. Like I said, you can make a list, and while doing this, you'll be able to decide if you have enough information once you see all of this together. And so next, let's take a look at devising a plan. This is where all the fun happens. So some questions you can ask yourself are, have you seen a similar problem before? And that similar problem could be a simpler one. It could be more general. It could be maybe even more specific. So you can think of things like that. You also can ask yourself if you can write the information as an algebraic equation. Maybe you want to think back to any formulas that you might know that maybe weren't given, but then if it asks for area and it's a rectangle, well, then you should be able to find that the formula for the area of a rectangle is length times width. Okay? When you're understanding the pattern and listing everything out, you now can look for patterns to see if there's any relationships in all of that information that's given. And you can also try to express the problem more simply. Sometimes the problem might have complicated numbers, either they're very large, or let's say they might have mixed numbers, so a whole part and a fraction, and a lot of times people don't like working with those. So, maybe change the problem up and just use whole numbers. Okay, this will at least help you to figure out how to solve the problem at hand and what kind of operations you need to do. So that's solving using simpler numbers. You can also, it's kind of in line with these two, is solve a special case of the problem. For example, maybe the problem is asking how many different ways can you arrange chairs in a restaurant. And so if you think of specific cases of arrangements, that'll help you to solve the bigger problem at hand. So that's an example maybe of solving a special case. Okay, so what about listing the information in a table if you didn't do that already in the understand the problem part? But by listing things in tables, it'll help you to maybe see a pattern. And then one of my favorites is working backwards. A lot of my practice problems and my classwork packets, they offer the solutions. So you can literally, if you're really stuck, look at the answer and then work backwards and really try to figure it out. But if you don't have the answer, you can still use this method by considering what the answer might be and then working backwards that way. So it's definitely a useful strategy. Well, once you figure out the strategy or heuristic that you want to use, you want to carry that plan out. And something you want to ask yourself at each step is, can you check your work? When you're done, you really want to try to not go on to the next thing and forget about this. You really want to look back and ask yourself, does this answer seem reasonable? Can I check it another way? And is there an alternative method that I can use to arrive at the same conclusion? Then you also want to think, maybe can this problem and this result help me solve something in the future, right? So we want to keep connecting our old knowledge, our present knowledge, and think about what we're going to learn in the future and how it can all connect. And so at this point, I'd like you to look at some of the problems that the author solved in the MyLab videos. You can also check out the videos I created for the classwork packet questions. So here's a little memory challenge. Can you recite the 4 phases of problem solving without looking back? Okay, number 1 is understand the problem. Number 2 is devise a plan. Number 3 is carry out that plan. And number 4 is look back. And you can also think about looking towards the future. Which of the 4 problem solving steps do you usually skip or rush through? And what are some questions you should ask yourself when you get stuck? And that's the difference between a problem and an exercise. A problem is something that you don't know how to solve and you're getting stuck. So this is normal. And we just want to learn how to work through those. Have a great day.